Hello, welcome back to our little corner on the web, where we go through math problems to hopefully encourage and nurture interest in math. Today, we'll be going over questions 1 through 3 of part 2 of the 26 PMO qualifying stage. Question 1. Today, the second day of the 12th month of the year of 2023 marks the start of the 26th Philippine Math Olympiad. What is the remainder when 2023 raised to the 12 raised to the 2 is divided by 26? Okay. So even without doing much here, we have an odd number that's raised to an even power, or actually it doesn't matter what power it is. It should be an odd number. It's divided by an even number. So the only two possible choices actually is 1 or 3. But let's figure out which one it really is. Okay. So we'll try to do a bit of a rewrite here. So 2023 raised to 12 squared is nothing more than 2023 to the 144. Okay. We want to take mod 26 of that, or meaning the remainder when it's divided by 26. So we can actually take the remainder first when 2023 is divided by 26, and we'll have a remainder 21. So 2023, the 144 is congruent to 21 raised to the 144 mod 26. Okay. We can rewrite 21 to the 144 as 21 squared to the 72 mod 26. And 21 squared is 441. When we take mod 26 of that, it is actually just -1, or congruent to -1 raised to 72 mod 26, which is 1 mod 26. Okay, so the answer here is A, 1. You could also have used something more, I guess, fancier for Maslow's theorem, or you could have just tried to brute force and find a pattern. Okay. Okay, moving on to the next question. Okay, question 2. There are 2,024 coins laid out in a row. For some positive integer x, at least 2/3 of the first x coins are heads, and at least 4/5 of the last x coins are tails. What is the maximum possible value of x? Hey, we're asked for the maximum value, and we're given 4 values here, so we'll make the choices sort of work for us, right? If 1380 works, we're done. So first we take, what is 2/3 of 1,380, and that's 920. And we take 4/5 of 1,380, that's 1,104. And sure enough, the sum is 2,024. So it works because we can just make, because we sort of are not given what it is, we can make the first 920 heads and the last 1,104 as tails. Okay. Actually, there's some in the middle that can sort of get mixed somewhere in the zone, but it sort of doesn't matter for our calculations here. It's just that 1,380 does work. Okay, so we're done. Okay, next question. Question 3. Find the remainder when the sum from n equals 1 to 2023 of 2023 raised to the n is divided by 15. Okay, so the same simplification as a while ago. Okay, we will try to first take 2023 mod 15, just to make our life a little easier. Oops, mod 15. And that is actually 13 mod 15. So we can rewrite what we have there as the summation from n equals 1 to 2023 of 13 raised to the n mod 15. So it's not quite as clear how to do maybe further simplification. So what I did is I tried to find mod 3 and mod 5 separately, and then we'll just combine them at the end. Okay. So if we take mod 3 of 13, okay, so we'll do analysis on mod 3 first. Then this is just the summation from 1 to 2023 of 13 mod 3 is 1 to the n. Okay, mod 3. So that means that we just have 23 ones. So in essence, we're only taking 2023 mod 3, okay, which is 1. Okay, so we know that the answer has to be 1 mod 3. All the choices are actually 1 mod 3. 4 is 1 mod 3, 7 is 1 mod 3, 10 and 13 are also 1 mod 3s. So the only question now is what is the answer mod 5? So mod 5, we can rewrite this now as summation from n equals 1 to 2023 of 3 to the n mod 5. Okay. So we can write the first few terms here, mod 5, right? 3 to the 1 is 3. 3 squared is 9, mod 5 is 4. 3 cubed is 27, mod 5 is 2. 3 to the 4th is 81, mod 5 is 1. And what you'll see is you'll find a pattern. And for those of you who knows FLT, the pattern should be 3 to the 4th, 3 to the 4th mod 5 equals 1. So it will indeed repeat, right? So it repeats every 4, right? And so there's going to be 23 terms here. So the last few terms will be 3 plus 4 plus 2. And what you'll notice is every 4 terms, the remainder mod 5 is actually 0. 0. So only the last 3 terms here matters. So 3 plus 4 plus 2 is 9. 9 mod 5 is 4. So what we're actually looking for is a number that's 4 mod 5. The only one that satisfies is A. So it is that the summation when divided by 15 will leave a remainder of 4. Okay. So moving on to the next question. Question 4, the integers from 1 to 2023 are written on a long blackboard in a straight line. Millie colors any number divisible by 23 in blue, any number divisible by 88 in yellow, any number divisible by both 23 and 88 in green, and any number not divisible by either in red. How many adjacent pairs of numbers have different colors? Okay, so first thing we notice is 23 and 88 are actually coprimes, meaning they don't share any factor except for 1. And 23 times 88 is already 24. So there will be no greens in our list because there will be no numbers that's divisible by both 23 and 88. Okay, so no green. So the only patterns we're looking for are potentially R, YR, R, BR, blue, or some combination of RY, BR, or RBYR. Okay, so RYR occurs when the multiples of 23 and 88 are not one off from each other, and the multiples of 88 are basically between non-multiples of 23 and 88. Okay, and then our red, blue, red is when it's the multiples of 23 in this case are not one off from a multiple of 88. So we can sort of try to find each one of these first, right? How many potential multiples of 23 and 88 are there? So here, this was 88. So we know that 88 times 23 is 2024. So there's actually 22 multiples of 88. Okay, 22 multiples. So they could potentially be some RYR. We'll deal with the overlaps later of these last two. So in this case, if we assume that we only have dealing with multiples of 88, there's actually 44 such pairs. One pair is this and one pair is that, right? So this gives us 44 pairs. And if we're only dealing with multiples of 23, there are 87 multiples. Okay, which means that there are 174 potential pairs if none of them were beside a multiple of 88. So the maximum, if none of them were beside each other, would be 218. So from the choices, we're only left with this or this. Okay, so again, which one, right? So now the question is, are there multiples of 88 and 23 that's one away from each other, right? Meaning an RYBR or RBYR, because that will decrement the count by 1 for each occurrence. Okay, so again, we'll do some modulo here. So we're basically looking for some 88 times some number congruent to 1 mod 23, or 88 times A is congruent to -1 mod 23. Okay, actually, if we find one, we already know that we're 216 because there should be another one. Okay, because the max is 218 without dealing with potential potential multiples that are 1 away. So 88A congruent to 1 mod 23 can be written as -4A congruent to 1 mod 23. And sure enough, just by a bit of trial and error, we get that A equals 17 satisfies this. Okay. A equals 17 will be 17 mod 23 is -6. So technically we have -4, -6 congruent to 1 mod 23, or 24 is congruent to 1 mod 23. So that satisfies it. And on the other one, 88 congruent to -1 mod 23, we have -4A congruent to -1 mod 23, right? And again, A equals 6 here satisfies. So we found two cases where they're 1 away, and you can actually verify these. What this means is 88 times 17, okay, -1 is equal to some multiple of 23, and it turns out in this case it's 23 times 65. And for the -1 mod 23, A being 6 actually means that 88 times 6 plus 1 is equal to some multiple of 23, and in this case it's actually 23 squared. Okay, so the answer for this is D, 216. Okay. So hopefully you found these solutions helpful and educational. If you did, do hit the like button and subscribe. Thank you for watching.